Hey, it's Richard. In this video, I'm going to give you an overview of OBC and Houston development for ORCASat. I'll give you a few pointers about how to set up your development environment, and I'll give a demonstration of a couple of key concepts related to using and communicating with the OBC. So first I'll talk about my editor and my development setup. I use Visual Studio Code as my editor when I'm writing firmware and working on Python for Houston. A lot of people on the team use this, although some people will edit firmware in Code Composer and Python in like PyCharm or something else. That's totally an option as well. But no matter what your editor is, a couple good things to do. The first one is set up like a workspace or a project and put the OBC firmware repo and GCS, which is Houston, into it so that you can just easily like open up files from both and edit them side by side without needing to change windows and stuff like that. Another good thing to do is have a terminal set up in your editor so that you can launch Houston easily. This is really helpful when you're like editing Houston itself, since you often need to quit it and then open it up again as you're making changes. Another good thing to do is make it easier to launch Houston. So the Houston README in the repository talks about starting a virtual environment and entering the virtual environment and then launching Python and then Houston.py to start the app up. And that's fine and it works, but it's a lot more convenient if you can just do it with one command, like Houston, which I have set up here. And I'll show you how I did that. I know it'll differ between systems a little bit, but basically you want to set up an alias in your terminal to run all these separate steps that you need to do. So let me just show you what my alias looks like. So first I cd into the repository, then I activate my virtual environment, and then I run Python 3 Houston.py. So it's a good idea to set up an alias on your system so that you can just run one command to launch Houston. So that being said, let's actually launch Houston here. And I'll talk a bit about how to set it up and a bit about how to send commands to the OBC, and then we'll talk about how to run tests as well. So this is Houston. This is the main screen, which you can use to send commands to the OBC. Let me just plug in my OBC here. And it's detected that and connected it up. The first time, if you're connecting the OBC to your own machine, you'll need to go into the settings and set up the serial port that you use for the eGSE connection. There are two different possible ways to connect to the OBC. The first is eGSE, which is electrical ground support equipment, and that's the small little purple board with a USB plug on it that is the wired connection to the OBC. This is typically what you'll want to use during development. Since it's a wired connection, it's very reliable and that kind of thing. The TTNC is the telemetry tracking and telecommand system, which is the radio of the CubeSat. So I don't have one connected here, but it also connects up to Houston, and you can click the switch to TTNC button if you've got one connected and send commands over the radio link, which is sometimes also a wired link, but sometimes wireless, but that's fine. We'll just assume we're using eGSE, and they basically both work the same once you've got them plugged in. So this is what we call the monitor tab, or like the main screen of Houston, and you can use it to send commands to the OBC. The first thing you need to do in order to send a command to the OBC is ping it, which will just kind of wake it up and get it ready to accept commands. And I'll just show you what happens if you don't do that. So I'll try to send an ACK command. And what'll happen behind the scenes is Houston will be doing some retries since the OBC isn't going to reply to this command yet. So this is all Houston doing some retries, and I think if we go to the terminal, you can see like the debug information about what's going on. And in a few seconds, this will just time out and it'll give us a pop-up. So there we go. And this just happened because we haven't pinged the OBC yet. So if I ping it, you see we sent the ping, which is here, and then we got the response, the ACK from it, and now I can send commands with these buttons, and it works just fine. So you need to ping the OBC after you plug it and unplug it, or if you reset it, or if you power cycle it some other way. To send a reset command to the OBC, use this NRST button. That's just a term for soft reset. It relates to what the pin is actually called. So this command won't send a reply to us, but if we ping it, you'll notice that it takes a few seconds before the OBC will actually reply. And you can also see, if you look at the board, the LED on it will flash slowly at the beginning, and then once it starts flashing quickly, the OBC is ready, and that's the same time as when it's sending these replies. So now ACKs work again as well, and that's all good. The other thing you can do from this screen is send commands manually to the OBC. So to demonstrate that, I'm going to do get per dir, which is another OBC command, and this will get into file downlinking. So what this command is telling us is that the OBC thinks it's January 1st, 2020, and it's on its 6th set of log files for this day. And basically, every time you reset the OBC, it will create a new set of files on its little file system. And these files are for things like error messages. There's a system log file where it just has like startup information and stuff. And then there are files for telemetry for the various things that the OBC is connected to. And this number here is every time you reset, it'll increment this number and it works itself into the file name. And all of the files for one day are stored in the same date, like directory. And the January 1st, 2020 date is just the default that the OBC starts up with until you tell it what time it actually is. So what I can do now is I can ls, so just file list, the root directory, and don't worry about this A, what that's for. The details are in the OBC manual, and you can see that we've got a couple of day directories and we've got some various other things, and then we can go into 01 Jan 2020 and see what's in there. So some of these other commands take a little longer to run, but it should reply in a second here. There we go. And there's all the messages. So what we're doing is we looked at what the OBC has in the January 2020 directory, and you can see we've got 0 through 6 file suffixes here. And so basically what the get per dir command told us is that the current set of files that the OBC is logging to are in January 1st, 2020, and they have the suffix number of 6. And all of these other files are from old resets and old test runs and things like that. So they're all old. what we can do now is downlink a file, and I'll show you how to open it. And this can be helpful if you're trying to debug errors. You can like downlink the error log and see what actually happened on the OBC. So the command for downlinking a file is called put request. That's just a term from the downlink protocol that we use. So 01 jan 2020 /syslog 6, and then I need a 0 at the end of this command. That's also described in the manual. And there we go, file downlink succeeded. So this downloaded the file from the OBC onto my local machine. And now to actually go look at it, I can go over to the File Viewer tab, and I can go into that directory, and I have to scroll way to the bottom. I've got a lot of files on here because I have old test runs and I downlink stuff a lot. So syslog 6, and I can load that, and these are all the messages that are loaded out of that log. And so this is helpful if you need to go look at what's actually in a file. So we've done commanding, we've done manual commanding, we've done file downlinking, we've done the directory structure. The last one I'll talk about is testing. So frequently we'll run all the tests on the OBC. So currently the default set of tests are just whatever runs when you have an OBC plugged in and you click run tests here. So I won't do it because it takes a while, but that's how you run the default set of tests. If you're using FlatSat, or if you've got a specific hardware setup, you should check the boxes that apply to your setup. So if you've got a payload connected, or you just want to run payload tests, check payload. If you've got a power system, check EPS, and so on. Another box that is useful is stop on first fail. What this will do is it'll run whichever test it's going to run, and if any of them fail, it will just quit the test run instead of running whichever tests come after it. And that's useful because a standard test run can take half an hour, and so if a test in the middle of that fails, you'll still have to wait like 15 minutes before you can like go interact with the OBC manually and go look at the test report file and stuff like that. So this can be a useful box to check if you're debugging a failure. The last thing I'll talk about is how to run certain tests. So there's a text box here, and you can type sort of all kinds of stuff into it. You can type the name of a specific test function, the name of a file with a bunch of tests in it. You can even type partial names of tests, and it will kind of match file names and function names and stuff and run whatever happens to match. So that's handy if you are working on a certain test, or don't want to run the whole half-hour set of tests at once. You can type just a name and then click run, and then it'll be a lot shorter usually. Another thing related to running tests is you can manually override that box in the code. And this is pretty useful if you're editing, like working on one test. When you change the test code, you need to quit Houston and start it back up again to run the test with those new changes. So instead of quitting Houston and then also typing the test name into that box we just did every time, which can get annoying if you're just burning through, like iterating on a single test, you can also just type the test name into this line here in the code, save it, and then it'll only run that one when you hit just run tests. You don't need to repeatedly type stuff in the box. So that can be kind of useful sometimes. Just make sure to undo it when you're done, or else you'll only ever be running that one test. And the last thing we'll talk about is the test report. So I'm just going to open up Chrome here, and I'll open my report. So it's a good idea to bookmark this. And the file to bookmark is just the report.html that is saved in your clone of Houston called GCS. And what this is the most recent test report that was generated. So this is helpful if you've got failures and you want to get another set of eyes on like debugging the failure. Copy the test report and paste it into Slack or a GitLab issue, because if people can't see the logs of what happened, there's really no way they can help you debug a failure. So this is how you do it. And usually what I'll do is go into my clone here, and the report's down somewhere. Report txt. Where is it? There it is. Report HTML. Yeah. So it's this file, and it's a good idea to bookmark it. And if you need help with a test or want to show that everything's working, you should copy this report file somewhere. And I'll just go back to Houston and think about, is there anything else we need to talk about? Not really. That's how to run tests, checkboxes, test report, and I think that's everything. So if you have any questions about ORCASat command and data handling development, just post in the Slack channel. Somebody will usually answer pretty quickly, and thanks for watching.